Continuing with trig, and this is sort of what we're going to focus on this year in terms of trig similar to last year. And then we're going to sort of go off in a little bit of a different direction with trig. So you guys know how to find missing sides and angles in right triangles using right triangle trig. But what happens, like I said before, if it's not a right triangle, or you will often see this word used for non-right triangles, oblique. All that means it's not a right triangle. It's a triangle, but not a right one. Okay, so here we have an example. So we've got a non-right triangle, ABC. We know the length of little a for BC, which is 10. We know angle A, which is 30. We know angle B, which is 65. We're asked to find AC, or we call it little b. Any ideas from what you know about trig right now? Natalie? Yes, you can find this angle. Yeah. But how can we find the side? Using the trig that you already know. The trig that you already know only involves what kind of triangles? So what could you do to this? Excellent. Make it two right triangles by drawing what we call an altitude or a height from C down to AB. Because, and this we did do last year, where we found some missing sides or angles involving more than one right triangle. So what I could do is I could say, okay, I'm just going to do that, do that. Well, in the green triangle, to find B, I don't have enough information, do I? I know an angle, but I need to know another side in order to figure out what B is. Okay? Well, this side happens to be the same as this side. Can I find this side using the blue one? Yes. What would the trig equation look like to find, well, we'll call it, let's just call it X. So I'm looking for opposite, I'm given hypotenuse, so yes, sine 65 degrees is equal to the opposite side over the hypotenuse 10. Multiply both sides by 10 to get x by itself. So I get 10 times the sine of 65 degrees is going to be x. How much? 9.1. Okay. So this is about 9.1, which is also the vertical side in the green right triangle, which means now I have enough information to find B. What would the trig equation look like to find B? Little sine again, 30 degrees equals 9.1 over B. Multiply everything by B to clear the fraction, and you get B times the sine of 30 degrees is equal to 9.1. Divide both sides by sine 30. And if I was a guessing man, I would say you get exactly 18.2. How did he know that? Guess what? You guys are going to know that by the end of this lesson. You will be able to tell me this without using a calculator. Okay? You will be able to tell me the cosine of 90 degrees without using a calculator. And it's something called the unit circle, which technically isn't done until grade 12, but I always like to do it in grade 11. Okay. Anyway, B is equal to 18.2. And that's our final. Well, that's a fair amount of work. We have to do trig twice. I mean, it's not a huge amount of work, but mathematicians are lazy. We want to find simpler ways to do things. So there is actually a way to do this with one equation. And you're kind of combining the two into a fraction equation. And when you do that, it is called the sine law. Okay? So the sine law states, and you will always get this formula. That if we've got triangle ABC, capitals, with little sides ABC, the ratio or the fraction of little a over the sine of its angle opposite, a over the sine of its angle opposite, will equal the same fraction or ratio as little b over the sine of its angle opposite, and it's going to equal the third side, c, over the sine of its angle opposite, capital C. That's the sine law. Sometimes you see these things flipped. So sine A over little a equals sine B over little b equals sine, it's the same thing. Okay? When do we use these things? When can we use this? I'm not going to worry about this too much right now. Because we're going to learn another trig law called cosine law. And one of the things we have to know is, how do we know when we're given a question whether we use sine law or cosine law? I'm going to wait to talk about that until we do cosine law. Because actually the best way to figure out which one to use is see if it's cosine law first, and if it isn't, use sine law. But basically sine law, if you know an angle and one of its opposite sides, you can use sine law. So if, say for example, we went back here and I said, okay, let's use sine law. Well, I know, or this side I'm trying to find, what's the measure of its angle opposite? 65. So one of the fractions I can write is b over sine 65. The other fraction has to contain numbers. What's the other fraction?
30.
Not 30.
Sorry.
Sine 30. And they equal each other according to sine law. Well, we got a fraction equation. When we have a single fraction on either side, there's actually a quick way to get rid of both denominators, and that's cross multiplying. So what you can do is b times sine 30 will equal the product of the other diagonal, 10 times sine 65. And how do we get b by itself? Well, we got to divide this sine 30. So that means b is going to be this whole thing. 10 times the sine of 65, and then divide that by the sine of 30. When you do that, you should get the same answer, or something very close. 18.1. So when you do this, you get b equals 18.1. Well, we got 18.2, but we did some different rounding. The rounding in there, we didn't do rounding here. We calculated this exactly. Okay, so this probably is more precise. But you see how one equation, it's much more efficient to use than having to split it up into two right triangles and then figure it out from there. Okay. So let's have a look at the next one. Over here. Bottom of the second page. We have a non-right triangle. We're given two angles, one of the sides, and we're asked to find one of the missing sides. First thing we need to do, like really with sine law, set up the equation, cross multiply, get the side by itself, and use your calculator. What does the equation look like? Sorry?
7.3 over sine 63.
Get the degrees equals. Remember, if you wrote this first, that's fine. Still going to give you the same answer after you cross multiply. Oh. Even that today. Cross multiply to clear the fractions. Doesn't matter which order you cross multiply is. I'll do 7.2 times the sine of 71 degrees is equal to the product of the other diagonal, c times the sine of 63 degrees. How do I get c by itself? Divide sine 63, which means I have to divide this side by sine 63. So now we're ready to use our calculator. 7.2 times the sine of 71 divide the sine of 63. I strongly encourage all of you to try your own rather than just waiting for the answer to make sure you know how to use it. What did we get as an answer?
7.6.
7.6 is correct. Okay. Next one. Again, we're asked to find the sine. How would you set this one up? Or do you see something wrong? Like, shouldn't I know the angle opposite 5 in order to set it up? So I need to know this, but I'm not given it. Can you figure it out? Yeah, because these three have to add to 180. So before we can actually use our formula, we have to find this angle. And it's 180 minus 35 minus 100. Or you just add 35 and 100. And you get 45 degrees. So you may have to figure out one of the angles first. But because we know an angle and its side opposite, that means we can use sine law. So therefore, I always like to start with the unknown first. Little b over what? Sine 100 degrees is equal to 5 over sine 45 degrees. See if you can finish it from there. We should be able to finish it from there. So after you cross multiply, you'll get b times sine 45 degrees equals equals 5 times sine 100. Divide both sides by sine 45. You don't even have to write this. But you can if you want, of course. And B is going to be approximately 6, 7. Like 7 exactly?
Yes, it's one.
Okay, so it's 7. Unless it's the nearest one. If it said nearest 10, you got to put the points here. Okay, the other situation with sine is an angle system. Now remember, when you find an angle using trig, your last step is always going to be inverse. Because it's sine law, you're going to do sine inverse at the very end. Guaranteed. But we just got to get there first. So, what does it look like? Well, we've got the side 21 over the sine of its angle opposite, which is what we're trying to find. That is going to equal the other side we're given over the sine of its angle opposite, which we are given. And then we do the same step to clear the fractions, cross multiply. And we're going to get what was it again? It was why I did that. 39 degrees. So we get 14 times the sine of x is equal to 21 times the sine of 39 degrees. We've got to get rid of two things here. The times 14 and then just the sine. So how do I get rid of times 14? I divide 14. And I'm left with sine x is equal to this calculation, 21 times the sine of 39 degrees divided by 14. How do I get rid of just sine? I'm at my last step. Sine inverse. Which means you've got a sine inverse this whole side. Again, that's something that you want to practice on your calculator because you may have to put parentheses into yours. It all depends. Like what I usually do, because I can use the previous answer, is I just do 21 times sine 39, divide that by 14, and I get an answer, and then I do the sine inverse of that answer. Oh, wait a minute. Something's wrong here. You're getting an error, aren't you? What am I doing wrong? I've done something wrong. 21 times sine 39 divided by 14. I get 1.44, which means, what the heck? What am I doing wrong? What's 21 times the sine of 39? Can somebody do that on theirs? 13. Why am I getting? Oh. I'm in radians. It was a little upsetting for a while. I think I'm happy now. There we go. Look at that. You guys are doing it right. I'm doing it wrong. 71? Nearest degree. Okay, so using sine law to find a missing side and missing angle. Last one I want to do is a sort of a problem situation that you'll usually get a diagram with. The next page is just a proof of the sine law. It's just a combination of it's just basically taking two separate ones and combining like we did. You don't need to worry about the proof, but I feel better putting it in there. Okay, so this one we actually don't have a diagram. So one of the challenges for this question is going to be, okay, let's make sure we draw the diagram correctly. So we've got a river. We've got 2 points X and Y that are on opposite sides of the river, not necessarily directly apart from each other. Okay, so I wouldn't put them directly apart. I would say put X here and put Y here. Because then you might get confused that it's a right triangle when it's actually not going to be. So they want to find the distance between them, and this is how surveyors actually find distance. Okay. So what Chelsea's going to do at point X is she's going to walk 150 meters to a point called Z. So she knows that this is 150 meters. She can then use an angle instrument to figure out two angles. The angle from when she's at X or ZXY, which is 60 degrees, and the angle when she walks to point Z. Sorry, this is 45 degrees. I'm mistaken. This is 45 degrees. That's ZXY, yes. And XZY is 60 degrees. So we need to find the distance from X to Y, not from Z to Y, from where she was originally seen. Okay, and because she walked this amount, she measured two angles and formed a triangle on right. We want to find this, so I'm going to call it. I'm just, for argument's sake, I'm going to call it little z because it's opposite capital Z. Like I said, well, I can say pretty much every time you're going to be given a diagram. Okay, this one we had to make it, but it's okay. All right, so what do I got to do first? I got to find this one. Right now, I don't know an angle and its opposites, or angle and its side opposite. But I can find this one by doing 180 minus 45 minus 60, which should give me 75 degrees. Now I should be able to set up sine law. Anybody want to take a shot? Z over sine 60 equals, and here's 150 over sine 75. Good. Cross multiply, divide both sides by sine 75, round to the nearest tenth of a meter, that's one decimal place. So we get, if we cross multiply, we get z times the sine of 75 is equal to 150 times the sine of 60 degrees. Divide both sides by sine 75, and z will be found by doing 150 times the sine of 60 degrees, and divide that by the sine of 75 degrees. You get approximately 134.5. and that's meters. So that's sine law. There will be situations where we can't use sine law. We don't have the right information to set up the equation, which means we need another law. And that's going to be cosine law, which we'll talk about tomorrow.